Welcome to the Explainer. If you've ever stared at one of those dense, heavily color-coded maps of India's minerals and just felt completely overwhelmed, yeah, you are absolutely not alone. It usually just looks like this crazy scattered mess of dots and chemical symbols. But today, we're going to change that. We are transforming those dry textbook stats into a living, breathing story. We're talking deep geology, intense tectonic history, and some pretty harsh economic realities. Plus, we're going to use some brilliant mental cheat codes to permanently map this out in your brain. Let's get into it. Okay, let's dive into this. Here's a massive geographical mystery for you. Why does a desert state like Rajasthan hold a near absolute monopoly on silver, while the southern state of Karnataka wears the crown for gold? I mean, is it just random luck? Absolutely not. There is a deeply rooted scientific reason for this. And by the end of this explainer, you're going to understand exactly how the ancient movements of the Earth dictated exactly where these precious metals ended up.
So, here's our roadmap for today. First, precious metals and ancient geology. Second, the industrial backbone. Third, Rajasthan's lost sea. Fourth, the bureaucratic mineral paradox. And finally, number 5, reserves versus production reality.
All right, starting with section 1, precious metals and ancient geology, unearthing the sparkle. To lock this data into our minds, we're going to use some incredibly effective memory tricks. The first cheat code you need to remember is this simple phrase, Khan me sona, Raj me chandi, which roughly translates to gold in the ear, silver in the kingdom. But the real trick here is the wordplay. Khan points directly to Karnataka, which leads the country in gold production, specifically in the famous Kolar and Hatti mines. And Raj? Well, that points to Rajasthan, the undisputed leader in silver. But let's actually look at the why here. Karnataka's gold isn't just sitting there randomly in the dirt. This whole region sits on something called the Dharwar Craton. Now, a craton is a piece of the Earth's crust that's remained incredibly stable for billions of years. Roughly 2.5 billion years ago, think about that scale for a second, there was this massive, violent upheaval right beneath the surface. Superheated magma just pushed its way up, carrying gold right along with it. It then settled and cooled deep into the crevices of these ancient rocks. That 2.5 billion-year-old volcanic chaos, that is the exact reason the Kolar goldfields exist today. And hey, speaking of ancient geological magic, let's talk about energy minerals. Think of the phrase "jadoo se uranium" or uranium by magic. This perfectly connects uranium to the Jaduguda mines over in Jharkhand. Uranium is this highly rare radioactive element, right? And it's only there because millions of years ago, ancient hydrothermal veins, basically these underground channels of superheated water, deposited it straight into the rocks. Now, compare that to thorium. You can remember this with the trick Mona Kerala Ke Tapar, meaning Mona on the shores of Kerala. This links the coastal monazite sands of Kerala to its abundant thorium deserves. So you've got one forged in boiling underground veins, and the other just washing up on ancient shores. Pretty wild, right?
Moving on to section 2, the industrial backbone, building the nation.
Okay, so we're shifting our focus away from the flashy precious metals and moving to the heavy ferrous metals. If you really want to know where the iron that builds a nation actually comes from, you just need to remember one simple code, OCKJ. Those are the top iron-producing states, right in order, Odisha, Chhattisgarh, Karnataka, and Jharkhand. And Odisha, it doesn't just lead the pack in high-quality hematite iron ore, it's also the top producer of chromite, which is absolutely crucial because when you mix chromite with iron, you get rust-resistant stainless steel. So it's literally no coincidence that Odisha is this massive steel hub. The geography practically designed it to be one from day one. Now, what's really interesting about this is the role of manganese. You can kind of think of manganese as the secret spice of the industrial world. Look, if you try to build a bridge or a skyscraper with just pure iron, it's incredibly brittle. Under heavy pressure, it wouldn't just bend, it would literally shatter like glass. No way you want to drive over that. So manganese, which is predominantly produced in Madhya Pradesh, remembered by the trick MP mein manganese ki bahar, is mixed right into the iron. This gives it the flexibility and immense strength it needs. It's the vital, essential ingredient that allows steel to actually survive extreme industrial stress.
Okay, let's just pause for a quick mental check to make sure this is all solidifying. The Kolar and Hatti mines are famous for which metal? Think back to our very first cheat code. Yup, Khan me sona. Khan equals Karnataka, sona equals gold. Boom, locked in.
All right, section 3, Rajasthan's lost sea, the geography of monopoly.
Let's move to what is arguably the most dramatic geological story in our entire explainer.
Rajasthan actually has a near 100% monopoly on producing certain industrial minerals in India. The mnemonic here is Sisa Dek Raj Ki Jeep Chili. Sisa is lead, Jeep sounds like gypsum, and Raj is Rajasthan. And you can add zinc or jasta to that list too. The Zawar mines in Rajasthan are globally famous for this. But why? Why on earth does this specific desert state hold an absolute monopoly on lead and zinc?
Well, millions of years ago, right where the bone-dry Thar Desert sits today, there was actually a vast, shallow ocean called the Tithys Sea. And over incredible, mind-boggling stretches of time, the sea completely evaporated. As the water vanished, it left behind these massive, massive deposits of minerals like gypsum. But the story didn't end there. Actually, scratch that, it was just getting started. Deep underground, tectonic plates collided, creating unimaginable heat and crushing pressure. This pressure literally cooked the old oceanic sedimentary rocks, transforming them into hard, metamorphic rocks. And during this intense heat wave, ores of lead and zinc melted and oozed straight into the rock crevices.
So the Zawar mines today, they are literally mining the remnants of an ancient vaporized ocean that was crushed by shifting continents. It's like a giant puzzle coming together. And here's the punchline that solves our opening mystery. Silver almost always co-occurs geologically with lead and zinc. So because Rajasthan's lost sea gave it a monopoly on lead and zinc, it naturally gave it the kingdom of silver as well. It was all just a package deal forged millions of years ago.
Section 4. The Bureaucratic Mineral Paradox, Science versus Administration. So we've talked a ton about nature and geology, but now we got to introduce a massive twist in the narrative: human bureaucracy. Take mica, for example, which is known as abruk in Hindi. The Kodama region in Jharkhand is globally famous for its mica deposits. You can remember this with Kod Mein Abruk. Now, mica is an absolutely incredible mineral. It's a brilliant insulator, which just means it doesn't conduct electricity or heat easily at all. Because of its incredibly unique scientific properties, mica is the absolute heartbeat of high-tech industries. I mean, you need it for toasters, computers, even advanced aerospace engineering. Scientifically speaking, it's a total superstar. But if you look at the MMDR Act, which is the law that governs mining in India, mica is officially classified merely as a minor mineral. Wait, how can something we put in spaceships be a minor mineral? Well, because the classification has literally zero to do with science. Major minerals like coal and uranium dictate national energy security, right? So the central government controls them. Minor minerals like sand, building stones, and yes, mica, are categorized this way simply so state governments can hand out local leases and collect the revenue themselves. It's a total paradox of administrative red tape versus scientific reality. So the crucial point is, well, it brings us to Section 5, Reserves versus Production Reality, the ultimate plot twist. This right here is where geography meets hard-hitting economics, and honestly, it's the biggest trap for anyone studying this field. Let's use a super simple analogy. Having a mineral reserve in your state, that's like having $100 million locked in a bank vault to which you don't have the key. Sure, on paper you're incredibly wealthy, but production, that is the actual cash you have in your pocket to spend today. And market dominance always belongs to the person with cash in their pocket. For example, Rajasthan has the largest copper reserves. They've got the biggest bank locker. But Madhya Pradesh actually produces the most copper. They have the cash in hand. Now, let's see how this dynamic plays out with coal. Odisha has the most colossal reserves of coal hidden underground, but Chhattisgarh actually produces the most coal year after year. Why is that? Because unlocking that bank vault is really expensive and incredibly complicated. In Chhattisgarh, the coal is often sitting right near the surface, which allows for really easy open-cast mining. But in Odisha, massive coal reserves are buried beneath these ancient, dense forests. To get that coal, you have to cut down the forest, which requires environmental clearances that can literally take decades. You need railway lines, massive infrastructure, huge capital. So geography gave Odisha the gift, sure, but human infrastructure and policy allowed Chhattisgarh to actually produce it. And this leads us to what we call Bihar's gold illusion. If you look at the raw data for gold reserves, Bihar actually sits on a massive fortune of unmined gold deep underground. But in terms of real production, they produce barely anything compared to Karnataka. So the takeaway here is absolutely crucial. Never confuse what a state holds buried in its soil with what it actually brings to the market. As we wrap up this explainer, we're returning to the deep sands of time.
We know India's uranium reserves are highly limited and require heavy imports just to keep the nuclear reactors running. But remember monazite on the shores of Kerala? India has some of the most abundant thorium reserves on the entire planet, sitting right on those beaches. So the ultimate question I want to leave you with is this. As technology advances, how will unlocking the ancient, sun-baked monazite sands of Kerala hold the master key to an entirely self-sufficient nuclear-powered future for India? It's a massive puzzle, and scientists are working to solve it right now. Thanks so much for joining me on this explainer, and keep your curiosity sharp.